Hello all and welcome to the Math 8 video for multi-step equations. Multi-step equations are going to work very much like any other equation we've done, except for, as you can probably guess by the title, there's going to be more than one step, actually more than two steps to all of these equations. But some of the main things you've got to be able to do when solving multi-step equations, well, the first two, as I've listed here, are you need to know how to distribute, so use the distributive property, and you need to know how to combine like terms. Okay. Now, if you know how to do both of those things, the other thing you need to know how to do is to solve two-step equations. But once again, if you know how to do technically those three things, distribute, combine like terms, solve a two-step equation, that's how every single one of these equations will work. And I'll demonstrate by just jumping right into some examples. So the rest of the time here, we're going to work some examples, give you some tips to look out for, give you some hints on how to maybe write things and do things with these, because they do vary very differently in terms of, which side the variable's on, if you have to distribute or not, if you have to combine like terms or not. With these, it's really just important to understand what the question's asking in the first place, okay? And I'll give you some tips on how to distinguish what you need to do in certain situations, okay? But with that being said, let's look at number one here. So with number one, we have 2x minus 8x plus 1 equals 49. Well, I do want to say that we can start by breaking this up. Just as always, we've got two sides of the equation. So when we are looking at both sides of the equation, what we need to do is we need to simplify both sides. Now, what I mean by both, when I say both sides, with these types of equations starting off, one of the sides is actually already simplified. We cannot simplify anything to do with 49. Okay, so 49's over here. We can't simplify that any. So I'm going to go ahead and write equals 49 because that's something we can't change. Okay, just yet. We can't. We will change it whenever we get into actually solving the equation. Right now, we're just doing some clerical work to try to say, okay, this side over here, well, it's not like we can subtract 1, then divide by 2, and divide by -8. Okay, so with this, we've got to be really, really careful and understand we need to combine like terms. So if you remember when we talked about this before, combining like terms means we can take our like terms of 2x and technically -8x, and we can actually combine those together, okay? And there's two ways you can think about this. You can do 2x minus 8x or 2x plus -8x. Either way, 2x and -8 kind of come together when you add those to be -6. And then there's an x that has to go with that, okay? Now, one habit that I've kind of gotten into is, okay, I know I've got these two terms that I just combined. Well, let's go ahead and mark those out. So now I can see, well, what's left over here? Well, in the process of combining those like terms, we still have this plus 1 that we can't combine with anything else on this side of the equation. So what has to happen with that is we just have to bring it down. Okay. Now, after that, you will see, and this will be a common theme throughout all these questions, is right here, we've got a two-step equation. Well, how do we solve a two-step equation? The same way we've solved every two-step equation we've done up to this point. Subtract 1, so deal with the subtraction or addition first here. And then divide by -6, so deal with the, in this case, multiplication. So we get x is -8. Okay. And honestly, that's pretty much all there is to it. Every single one of these questions, after you either distribute, combine like terms, or as you'll see later, do both of those things. So some questions require you to do both. The result you should get is a two-step equation, and that should be the easy part right now, is going through and solving the two-step equation. That's why it's so important to know how to solve two-step equations and why it's one of the most important things to know how to do in algebra. Okay, but let's go on to number two. Number two, same kind of thing here, except for things are kind of flipped around. So when I draw my line down here to split the equation in half, this negative 19 over here, I can't do anything with that. Okay, so negative 19 is going to equal whatever I get when I simplify this over here. Just out of habit, I like to look at my variable terms. Well, there's actually only one variable term, this negative 3a or minus 3a. So in that case, my hint for you with these types of questions is always look at what's in front of a term, because that's going to tell you if it's positive or negative. So in this case, we have 3a, and it's actually negative because there's a minus in front of it. So let's go ahead and write that down, considering I can't combine it with anything over here. But what's left over is what I can combine, this negative 5. And in a way, you can think of this as a negative 11 or minus 11, okay? So when you look at this, negative 5 minus 11 or negative 5 plus negative 11, we get that the combination there gives us negative 16. So we write minus 16. And once again, so you can go through and cross out the ones that you've gotten, you've dealt with. And then what do we end up with? Well, we end up with a two-step equation where we just do the same steps every time. Okay? So notice I am kind of brushing through the two-step equation process because at this point, everybody should know how to do two-step equations. If you don't know how to do two-step equations, I do suggest going back and looking at the two-step equations sections to really understand how these work, because like I said, you're going to be doing it every single question in this section. Okay. So number 3, 19 is equal to, and then you've got this big mess of stuff over here with variables and numbers. Okay. But same thing's still true. If we put the line down through here, we can't do anything with this 19 yet. But what can we combine over here? Well, we can combine this minus 5w or negative 5w with this positive 9w or plus 9w. So doing the variable terms first, we get negative 5 plus 9 gives us 4w. Once again, if it helps when you have so many terms, just cancel, cross those out, and then see what's left over. Well, what's left over is we have 10 and negative 7, or 10 minus 7. And what 10 minus 7 is a positive 3. Or you can think of it as 10 plus negative 7 is still a positive 3. And then just like always, two-step equation. Like I said, I'm going to not spend so much time on the two-step equation. If you need to know how to do two-step equations, then go back and look at those sections. But solve the two-step equation and you're done. So the trick to these are figure out what you can combine, what you can simplify, and simplify it down into a two-step equation. Number 4, exact same thing, except for it's flipped back around now, so we can't do anything with the negative 48 yet until we clean this up over here. But at the same time, what can we combine? Well, we can combine the positive 2k and the positive 3k. All right, so if we do 2k plus 3k, we get 5k. Okay, and that's taking care of those. Well, now what is left? What else can we combine? Well, we can combine this negative 6 and this negative 7, or minus 6 minus 7. So if you minus 6, then minus 7, that's the same thing as minusing 13. So you can think of it as negative 6 plus negative 7, or negative 6 minus 7. Still, you'll get negative 13 here. Okay, and then like I said, if you need to, all right, we're done. There's nothing else we can combine, so two-step equation. Okay. Divide by 5, so we get k is equal to negative 7. Okay. So that's an example. So those 4 examples are ones of combining like terms. So notice every one of those examples, we had to combine like terms before we could solve the equation. Well, now let's look at some examples. So examples 5 through 8 here. These to me are maybe a little bit easier, but you really need to know how to distribute, because 5 through 8, what you've got to do is you've got to distribute. So use the distributive property, and then after you use the distributive property, then you can solve the two-step equation. And what I mean by that is, well, let's look at number 5. Well, first off, we remember how to use the distributive property. We recognize that what gives away the distributive property here are the parentheses. Okay, so I'm just going to go ahead and tell you pretty much, and I say 95% of the time, you'll see why in algebra, in actual algebra class, why I say 95% of the time, because there are some corner cases where parentheses don't actually mean that you need to distribute anything. But I'll go ahead and tell you, pretty much every equation that you see in this class, if you see parentheses, that's an indication for you to distribute. So as soon as you see parentheses, you need to know I'm distributing something. Okay, so we see parentheses here. It's telling us we need to distribute the 7, which means we take the 7 and multiply it times both of these, which once again, something you should already know how to do. But if not, maybe go back and look at the distributive property section, okay? But once we do that, 7 times x gives me 7x minus, or you can think of this as a negative 6 in here, so 7 times negative 6 gives me a negative 42. Not draw my line in there, so it's a little crooked. But that's what I did when I distributed. And once again, I can't do anything with this negative 14 over here because it's just by itself over here on the right-hand side. But now that we've cleaned this up and we distributed, same exact thing as what we've done before, which is solve a two-step equation. In this case, we get 28. And in this case, divide by 7, x is equal to 4. Okay. So once again, the key with these questions like this is distributing. Okay. And notice all of these, so 5, 6, 7, and 8, that's all you really got to do. You got to distribute, then solve a two-step equation. So with number 6, let me go ahead and draw my lines before I forget. So in this case, 16's over here. I can't do anything with that. But I can do negative 2. So negative 2 is what we're distributing now. I can distribute my negative 2, which means I do negative 2 times k, which is negative 2k. Negative 2 times a positive 9 or plus 9 is going to give me a minus 18. Okay. So if you're a little rusty on distributing, remember distributing a negative kind of flips the signs around here. So instead of a plus here, we should have a minus. So negative 2 times k is negative 2k. Negative 2 times positive 9 or plus 9 gives me a minus 18. Okay. And same exact thing. Two-step equation. Do all the steps that we would do there. So we get negative 17 is equal to k. All right. Same thing with number 7. Should be pretty easy here because once again, we see the parentheses means we need to distribute this 4. Same thing as all the rest though. Negative 52, we can't do anything with that yet. So it's over here. We can't simplify anything, but we can simplify this into 12n minus 4. Because once again, 4 times 3 is 12. The n has to go with it. And then you can either think of this one of two ways. You can think of this as minus 1, so 4 times 1 is 4, so minus 4. Or you can think of this as a negative 1, so 4 times negative 1 gives me a negative 4. And like I said, always the same thing here. Two-step equation time. So in this case, we get negative 4 is equal to n. All right, and then the last one here, important one because I'll put a little star by this one, a couple stars, because the importance of this one is dealing with the fraction here. Well, we deal with a fraction the same way we deal with any other number. We just distribute this fraction, okay, because it's a number. It's directly outside in front of the parentheses, so that means we distribute that. And then all we have to do is multiply 1/2 times 12. Well, technically negative 1/2 times 12. Negative times a positive will give me a negative 6p. And this is still equal to negative 33. So what do we do about this? Well, once again, we got to remember a negative. So think of this as negative 1/2 times a negative 42. So negative times a negative should give me a positive 1/2 of 42 is 21. Like I said, if you have trouble with fractions, the Desmos calculator is very friendly when dealing with fractions. Just make sure you're keeping track of your negatives and you're distributing to both terms. But after you do that, two-step equation time. And divide by -6. So we get P in this case is equal to 9. Okay. So once again, even if there's fractions there, you treat them just like any other number. You would distribute the number -2, well, you can distribute the number -1/2. Okay, you can distribute the number negative, or you can distribute the number 2/3 like you will in number 10. Okay, so don't let fractions trip you up in that. Once again, they just work just like any other number. You can distribute a fraction. Okay. But then we get to ones like number 9. And for the rest of these, okay, so numbers 1 through 8 there, those are all questions that you either have to combine like terms or distribute. You don't have to do both. Well, starting with number 9, you actually have to do both. And you have to do them in a specific order. Okay, so you have to do them in the order. You have to distribute first, then you can combine like terms. Once again, it has to be in that order. And the reason that is because, well, what do you do when you distribute? You multiply. What do you do when you combine like terms? Well, you add or subtract. Okay, so multiplication in terms of order of operations, because that's what we need to follow here. Multiplication comes before addition or subtraction. And once again, we're not solving the equation when we're doing that just yet. We're just setting the equation up to be solved, meaning we're just simplifying this over here. So once again, first things first is distribute. Well, what tells us we need to distribute? The parentheses. So we take this 5 and we're going to distribute the 5. So 5 times y minus, or you can think of it as 5 times -2 is a -10. That's all we need to do with distributing, but then there's still something left over. We didn't do anything with this -7y, so we just bring it right down. And then, of course, the same as always, this number over here, we can't simplify it, okay? So we got to wait till we can solve the equation, okay? But then we get to this point, combine like terms. Well, what can I combine together? Well, I can combine this positive 5y with this negative 7y. So positive 5y, either, once again, you can think of it as either way, 5y minus 7y or 5y plus -7y. Either way, you're going to get -2y. Okay, once again, you combine those terms, they're gone. What's left? Well, the only thing that's left over here is this -10 or -10, so it just comes right down. And once again, we just did both things, so we distributed and we combine like terms, but now after we did that, we just solve the two-step equation. Okay, so plus 10 plus 10, we get -2y is equal to, in this case, -22. Divide by -2, divide by -2, y is equal to positive 11. Okay, and once again, I'm kind of going really quick with the two-step equations because at this point, that's something you really need to know how to do. If you're struggling with the two-step equation, so if you're struggling from here down, that's cause for concern at this point because you really got to know how to do it. Because like I said, every single one of these, you got to solve a two-step equation. So the thing we need to recognize about these types of questions is if you have both combining like terms and distributing, okay, as evidenced by the parentheses here, then you have to distribute first, then combine like terms. So if we look at number 10, okay, what we have here is -3 plus 2/3, and then in parentheses, 6n minus 42, and that's all equal to -51. Well, same thing here. First things first, I can't do anything with the -51. I'm just going to write it over here again. But then we got to pay attention. Well, what do we got to do first? Well, we have to distribute first. Well, what tells us we need to distribute? The parentheses. So I want to point out -3 isn't part of the distributing here. So I'm just going to go ahead and write -3 down here. But what is part of the distributing? What am I distributing? Well, I'm distributing a positive 2/3. Okay. And this is again where, if you have trouble with fractions, Desmos works out pretty nicely. Okay. But it actually works out pretty nicely. If you do 2/3 times 6, you actually get a positive 4n. Okay. So 2/3 times 6n, positive 4n. So 2/3 times 6 is 4. N has to go with it. Positive 2/3 times a negative 42 is going to give me a negative or minus 28. Once again, you can double check that on a calculator if you need to, but this fraction works out pretty nice. Even though it is a fraction, it works out with these numbers because 2/3 of 6 is 4. 2/3 of 42 is 28. Okay. And then, once again, after we distribute, combine any like terms we can. Well, I can't combine anything with this 4n, so I'm just going to go ahead and write 4n again and equals 51 over here because it's staying the same. But what can we combine? So I couldn't combine anything with the 4n, but I can combine -3 and -28, or -3 minus 28, which gives me a negative or minus 31. Okay. So like I said, know how to deal with your negatives here. And like I said before, the big hint here is whether you're distributing or combining like terms, always look at the term and what's in front of it because it tells you if it's positive or negative. Here, the plus tells you need to distribute a positive 2/3. Here, the minus or the negative tells you, well, I can combine -3 and -28 to give me -31. And as always, same steps. 4n is equal to -51 plus 31. That's -20. So I apologize for that. -20. And then divide by 4. So we get -5. Okay. And all the rest of these pretty much work the same. Okay. So as you go through numbers 11 and 16, I do maybe suggest pausing the video in certain places and maybe trying these yourself and then unpausing the video and coming back through and watching how I do it, just to kind of get some practice here and see how these are done, because this is pretty much it. Now, I do have to say, ones like numbers 11 through 16, these are more like what you will see in terms of having to distribute and combine like terms. But I'll be honest, if you know how to do numbers 11 through 16 here, then ones like numbers 1 through 8 should not be a problem because those are even easier because you only have to do one or the other, okay? But what tells you what to do, the first thing you should ask with an equation is, are there parentheses? And if there are parentheses, that tells you need to distribute, okay? So for this equation, same thing. Over here is 57. I can't do anything with that. Okay, but I can do something with this -3. I can distribute this -3. So -3 times 4v gives me -12v. -3 times a positive 1 or plus 1 is going to give me a -3. And then once again, we didn't do anything. This 2v, this plus 2v over here, has nothing to do with the parentheses or the distributing. Okay, so we just bring it down. So there's the distributing. So the next step is to combine like terms. Well, I can combine the -12v with this positive 2v. And if I combine those two together, -12 plus 2 or -12, well, plus 2, it doesn't, plus positive 2, I guess you could say, would give you -10v. And then what's left? Well, this -3 or -3, so it's -3. And then at that point, easy mode should come on, solve the two-step equation. And there you go. -6 is equal to v. 12, same exact thing. Parentheses are there. Means you got to distribute. Well, what are we distributing? Well, what's in front of the parentheses? Well, it's a 7, positive 7, so that's what we're distributing. 7 times 3k gives me 21k. 7 times negative 2, or 7 times 2 with a minus here, means we're going to subtract 14. So 7 times 2 is 14, so 7 times negative 2 is negative 14. And then at the same time, kind of like number 11, this minus 13k is just hanging out because it has nothing to do with my distributing. But now that I'm done with the distributing, now I can go and combine the 21k with the negative 13k or the minus 13k. So 21k minus 13k, 21k plus negative 13k gives me 8k. And what's left over? We have the minus 14 here. We can't combine with anything over here, so it just stays minus 14. And same thing over and over again. Solve a two-step equation. Divide by 8, and k in this case is 12. Once again, it all goes back to being able to keep track of your terms up here after you distribute. Okay, so if you have to distribute, that's the first thing you've got to do. Then you can worry about combining what terms you don't that you have. Okay. Number 13 and 14, same exact thing. A little tricky here because if we look, if you need to, maybe put a little star. I'm going to put stars around 14 because this is a special case that really need to understand how it works. Okay. But if we look at number 13, well, what are we distributing? Well, we can't do anything to this negative 3, so let's just leave that there. Negative 15 minus 2, and then we see the parentheses. And the parentheses tell us we need to distribute what's in front of it. So in this case, we got to distribute 2, but then we also got to think, was that a positive or negative 2? And in this case, it's actually a negative 2. So since it's minus 2, you distribute the negative 2. The negative 15 has nothing to do with the distributing. The minus 3 has nothing to do with the distributing, but let's wait until we fill this out. Negative 2 times c is minus or negative 2c. Negative 2 times negative 1 or minus 1 gives me a positive 2. And then we can add this minus 3c because, once again, all we need to focus on is what we're distributing right now. Now, after we're done distributing, then it comes into looking at the like terms we can combine. So we get negative 3 is equal to negative 15, negative 2c, negative 3c. Well, those will combine to give us, well, actually messed up right there because normally I like to combine my like terms here. So I'm going to combine negative 2c and negative 3c to give me negative 5c. Okay, so we dealt with those. Now what's left over? Well, we still have negative 15 and positive 2. So negative 15 plus positive 2 gives me a minus 13 or negative 13. And two-step equation time. So 13 or negative 3 plus 13 is 10. Divide by negative 5. Negative 2 is equal to c. Okay. And once again, the trick on this one is, and this is a big thing to remember, is not only do you have to worry about the number that's in front of the parentheses, you also have to worry about what sign is in front of that number. Is it a positive or a negative? Okay. Same things with number 14. Okay, so let's look at this one real quick. Negative 18, can't do anything with that. So that's going to be equal to 5 minus, and then in parentheses, 6k minus 19. Well, this one's a little tricky because if we look, we see the parentheses and we know we have to distribute something. But if you look in front of the parentheses, there's no number. And if you remember back what we did with this when we did distributive property, there's just a negative or minus right outside the parentheses. Technically, that means you need to distribute a negative 1. Okay, so negative 1 is what we're distributing. So once again, the 5 has nothing to do with that. But then we do negative 1 times 6k, which is negative or minus 6k. Negative 1 times negative 19, or negative 1 times minus 19 should give us a plus 19. And then we go through and do the same thing. So combine like terms. Can't do anything on the left again, but I look and see, well, can I combine anything with this negative 6k? Well, no, I can't. So let's just write it down again. But what's left over, 5 and 19, I can combine. So 5 plus 19 actually gives me positive 24. Okay, and then, like I said, same thing. Two-step equation, minus 18. So here we get negative 42 is equal to negative 6k. Divide by negative 6, divide by negative 6. Negative over negative is a positive 7. And then we get k over here. So 7 is equal to k. All right. So like I said, the reason I put stars on this one is to remember, okay, even though there's not a number in front of the parentheses, we can include a 1 in there so we know that's what we're distributing. We're distributing a negative 1. Okay. And then once you figure that out, it works the same as number 13 or number 12 or number 11 or number 9 or number 10. Okay. So once again, just be aware of what's outside the parentheses, so what's immediately in front of the parentheses, and what sign it is. Is it negative? Is it positive? Is it negative? Is it positive? Is it positive? Okay. So always looking ahead of every term and every set of parentheses. And then we get to the last two here for this section of the multi-step equations, which is r minus 3, and then in parentheses you have r minus 9 plus 4 equals 5. Now once again, let's separate sides of the equation. So we know on this side we're going to have 5, but we see the parentheses, and this is where we need to know, well, I need to distribute. So if we look, technically we need to distribute this negative 3. A lot of people just want to distribute the 3, but we need to distribute a negative 3, whereas r doesn't have anything to do with it. Negative 3 times r gives me minus 3r, or negative 3r. Negative 3 times negative 9 should give me a positive 27, and then this plus 4 had nothing to do with it, so we kind of just have to tack it on. Now, one thing you can do is, instead of just putting r here, you can say that that's 1r, okay, because technically in front of every variable or every set of parentheses, there is a number, okay? But if that number is not expressly written out, that's understood to be 1. But then it's the same exact thing. I can combine this 1r and this negative 3r. Well, 1r minus 3r, that's negative 2r. And then what's left over? Well, I have plus 27 plus 4. So if I add 27 and 4, I get 31. Okay, like I said, if it helps you cross them out as you combine them, so that way you know you've got all your terms. And then here, two-step equation time. I think I'm going to get that put on a shirt or something, two-step equation time. But here we get 5 minus 31, that's negative 26. Divide by negative 2. R is equal to positive, so negative over a negative is a positive 13. Okay. Now, and then we get to number 16, which is the toughest of them all. And I'll go ahead and tell you, if you know how to do number 16, okay, once again, I suggest maybe trying it yourself. But if you can do this one, then any equation you have to do like this should be no problem to you. Because number 16 is a little bit more difficult in that you actually have to distribute twice. You see two sets of parentheses. Okay, let's go ahead and draw our little line down through there. So first off, this first set of parentheses, well, what are we distributing here? Well, we're distributing a 6. Okay, so 6 times 8 gives me 48. 6 times negative 3x, or 6 times 3x, so 18, but there's a minus there, so it should be minus 18x. And now we're done with the distributing, so let's mark that out. Well, what's left? Well, now we need to distribute, 2 with a negative, so negative 2. So we get negative 2 times x, which is minus 2x. Negative 2 times positive 1 is a minus 2. And then same thing as always here. Combine what like terms we can. So I can combine this negative 18x and this negative 2x to give me negative 20x. And then I can combine this 48 and this minus 2. I see a typo, or I see a righto that I did. So let's go back and start this one over, and I do apologize for that, because some of you probably were looking at the screen and thinking, well, that equation's not right. That's because I accidentally wrote the wrong equation down. So let's start from the top on number 16. Okay, so that stays the same. But here we have minus, and then in parentheses is the 2x plus 1. And that's equal to 107. Okay, so same steps pretty much here. Okay, distribute the 6. So we get 6 times 8 is 48. 6 times negative 3x is negative 18x, okay, or minus 18x. And then here's where it changes, is I had the 2 on the outside of the parentheses, whereas if you look on the sheet there, it's actually 2 on the inside of the parentheses. But regardless, we still have to distribute because there's parentheses. Well, what are we distributing? Well, just like in number 14, we need to distribute a negative 1. Okay, once again, we already took care of that distributing. Let's do this one. So negative 1 times 2x is negative 2x. Negative 1 times positive 1 is a negative 1. I'm going to shift this over just a little bit so that way I have a little more room over here at this 107. Went off the rails here with number 16. Okay. But same kind of thing is we take our variable terms here. Negative 18, negative 2 gives me negative 20x. So get rid of those. What's left? 48 minus 1. 48 minus 1 gives me a positive 47. Okay. Now this looks a little better because now we solve the two-step equation. We subtract 47. Negative 20x is equal to, in this case, 60. Divide by negative 20. X is actually negative 3. Okay, so a little hiccup there because accidentally, and I do apologize for that, accidentally writing the wrong equation. But once we got the equation fixed, same steps. And this one's the toughest one because you had to distribute twice. You also had to notice that since there was just a minus in front of the parentheses, we're technically distributing a negative 1. Okay, that's where I suggest going back and looking at number 14. But the parentheses, just if you have parentheses in general in an equation, that means you need to distribute something. And in this case, it's technically distributing a negative 1. Okay. So with that being said, you can complete the first part of the homework. Now, this section's a little bit different in that there's actually 2 sets of homework. So there's technically a total of 24 questions for homework, which seems like a lot. Okay. But I just want to say when we go on to the next section, so I would go ahead and do the 12 questions for the homework for multi-step equations with the variables on one side. Because now what we're going to do is, for the last part of this video, is we're going to look at multi-step equations where you have variables on both sides. Okay, so the thing to keep in mind here that this works exactly the same. So we're going to go through pretty much the same steps as before. We're just going to add or subtract a variable term on both sides. And I could say that in words, and you might not understand what I mean by that. But when we look at some examples, it works exactly the same as what we just did. Okay, except there's one extra step where we have to add or subtract a variable term on both sides. Okay. Now, another note with that is to make sure you simplify as much as possible before getting rid of the variable term from one side, okay? So what I mean by that is, in this case, you're actually going to have to simplify maybe 2 different sides of the equation. And then, like I said, we're going to get rid of a variable term from one side, and I'll show you exactly how to do that when we look at example 1. Okay, so like I said, same exact steps here except for one added step. And we're going to see that one added step right off the bat. So if we look, we got both sides of the equation. 8x plus 17. I can't simplify that any because 8 has an x, 17 does not. We can't add those two numbers together, so that has to stay like that. 2x plus 35, same reasons. 2 has an x, 35 does not. We can't add those together. So how do we proceed here? Well, in this case, we can't subtract 17 from both sides, or we can't subtract 35 from both sides because we actually have a variable still on both sides. Well, this is what I mean by taking and getting rid of a variable term from one of the sides. And it's actually up to you which variable you get rid of, okay? So when you look at these, you have an 8x on this side, you have a 2x on this side. So you have a choice. You can either subtract 8x from this side, or you can subtract 2x from this side. And once again, it actually doesn't matter, but as you'll see, I usually like to just go ahead and always get rid of the variable term on the right-hand side, meaning, in this case, I'm going to subtract 2x. Because I want to get rid of this 2x. And that's what exactly will happen if I subtract 2x. Those 2x's will go away. But we can't forget this is an equation, so if I subtract 2x from this side, I have to do the same thing to the other side. But what can I subtract 2x from? Well, it would be this 8x. Okay? So I can't subtract 2x from 17, but I can subtract 2x from 8x. And 8x minus 2x gives me 6x. We didn't do anything with this 17, so it's still plus 17. We got rid of the 2x, and what's left? Well, a positive 35. And lo and behold, after we do that step, two-step equation time. I think I will get that put on a shirt, actually. So two-step equation here. So we get 6x is equal to 35 minus 17. Kind of a little tricky there. Some numbers you're not maybe familiar with, but that would leave you with 18. And then we just divide by 6. So x is equal to 3. Okay, so notice what I had to do here, and that's the way the first few examples here will work. Actually, same as kind of last time, 1 through 8. You're just going to have to figure out, okay, what's my variable terms, and then take away one of them, or in some cases you might have to add, and you'll see that actually when we get to number 4. Sometimes you might have to add a variable term on each side, okay? Just depending on whether the variable term is positive or negative, which goes back to looking at your terms and seeing what's in front of them, okay? So when we look at number 2, we have 7k plus 8 equals 2k minus 37. Once again, I can't simplify either one of these sides any. There's no like terms, there's no parentheses, I can't do anything. So the only thing I can do is I can either subtract 7k from both sides, or I can subtract 2k from both sides. And I'm actually going to go with the latter again. I'm going to subtract 2k here, get rid of those. Well, which term over here can I subtract 2k from? Well, I can subtract it from the 7k. So 7k minus 2k gives me 5k. We still have the plus 8. And that's going to be equal to, well, the 2k's over here cancel out, so we're going to still be left with minus 37, or negative 37. And from there, two-step equation time. So boom, 5k is equal to negative 37 minus 8. It's going to give us a negative 45. Divide by 5, divide by 5. We get k is equal to negative over positive, negative 9. Okay. So notice what I had to do there. Since I had a variable term on each side, I had to get rid of one of them, okay? And like I said, it actually really doesn't matter which one you do. You could have subtracted the 7k, but I just like getting rid of my variable term on the right-hand side so that it looks like a more traditional equation like we're used to solving, okay? When you look at number 3, it makes it a little hard here because we have m plus 3 is equal to 9m minus 13. Same kind of thing here. Both sides of the equation, I can't simplify. So I've got a choice. I can either subtract 1m from both sides, or I can subtract 9m from both sides. Okay, and once again, normally I just like to do the left hand or the right hand side, so subtract the 9m. But I want to show you, you can actually subtract the 1m. So if I do that, those are going to go away. Subtract the 1m over here. Well, what's left over here? We have positive 3, so we get 3 is equal to 9m minus 1m gives me 8m, and then we still have the minus 13. Okay, so once again, two-step equation, add 13, we get 16 is equal to 8m, 2 is equal to m. All right, so like I said, this was an example where maybe I want to subtract the term from the left-hand side instead. And as you get better with these and as you practice with these, it kind of becomes more clear which one you should maybe do. Like I said, I like to normally do it on the right-hand side, so get rid of the right-hand side term, meaning I would maybe subtract 9 from both sides. But in this case, it makes a little more sense for me to subtract the 1m, because if I do 9m minus 1m, that gives me a positive 8m, and that's one less negative I have to deal with. Whereas if I did it the other way around, I would subtract the 9m, well, I would have to do minus 9m. That would give me a negative 8m over here. And once again, it would still work out to be the same. You would still get m is equal to 2, but in this case, you would have had to deal with dividing by a negative. But then we get to number 4, okay? Number 4, I'll put some stars by this one because this one's kind of special in that we have negative 4y plus 6 equals negative 3y plus 12. So once again, two different sides of the equation, but I wanted you to notice about the variable terms. Okay, well, first off, I can't simplify this any. The negative 4 has a y, the 6 does not. The negative 3 has a y, the 12 does not. So I can't simplify either side. So I just have to go straight into either get rid of one of the variable terms. Okay, and in this case, once again, it might be hard to choose. So you can either add 3y here, or you can add 4y. Okay. And the reason you want to add here instead of subtract is these variable terms are negative. Okay. So once again, your goal is to get rid of one of the terms. Well, how do you get rid of a negative? Well, you can add a positive to it. Okay. So just like over here, I'm going to actually do it on this side. I'm actually going to add 4y on this side because negative 4y plus 4y, those are going to go away. So when we do this, we got to do negative 3y plus 4y. So what do we have? We have 6 is equal to negative 3y plus 4y. Well, negative 3 plus 4 will give me 1y. We still have the plus 12. And then from here, it's actually just a simple, not minus 6, minus 12. Okay, so we get 6 minus 12 is negative 6. And then we get 1y left over, but I'm just going to call that y. Now, if you take the 1y down here and divide by 1, you still come out with the same answer. But y in this case is negative 6. But I just want to show you two different things with number 4 is that sometimes you've got to add a variable term. Okay, and that's what I say right here. Add or subtract a variable term. And what makes the difference where you add or subtract is whether your term is positive. So if your term's positive, you got to subtract it. Or if your term's negative, in that case, you need to add the term. Okay. So then we look at number 5. Same kind of thing here. Two sides of the equation. We get 6a plus 40 is equal to 2a. So once again, on either side, I can't simplify any, so I can't do anything with this over here. I can't simplify 2a. So once again, you got a choice. You can either subtract 6a from both sides, or you can subtract 2a. And I'm actually feeling pretty adventurous. I'm going to subtract 2a. But if I do it over here, then I have to do it on this side. So 6a minus 2a, that gives me 4a. I haven't done anything with the plus 40, but we have a unique situation happen here. If I do 2a minus 2a and there's nothing else over here, well, when we cancel this out, that technically means that there's actually a 0 there. 2a minus 2a, a number minus itself, is always 0. So we actually end up with the two-step equation 4a plus 40 equals 0, where we work our two-step magic. Okay, so 0 minus 40 is negative 40 divided by 4. A is equal to negative 10. Okay, but I just did want to point out, once again, that you could have as easily subtracted 6a from both sides and gotten negative 4a over here, and 40. Divide both sides by negative 4, you still get negative 10 as a. Okay, but like I said, it's either or. You can either do one variable term or the other. Okay, same thing with number 6. I'm going to do a little bit of doctoring in number 6, though. Once again, we got two different sides. I can't do anything with 5w minus 29, so I'm actually going to rewrite that. You'll see why I'm going to rewrite it here in a second, because over here I've got 55 minus 2w. Once again, this is a little weird than what we're used to. We're used to having the variable term first, so that's what I suggest you do. I could move this variable term to the front, and then that would be plus 55. Now we have the same thing as what we've been working here on the last 5 examples, which is I can either do one of two things. I can subtract 5w from both sides, or I could add, so in this case add, because this is a negative 2w, I could add 2w to both sides, which is what I'm actually going to do. Once again, the whole point in doing that is to get rid of this variable term. Over here we would just have positive 55, and on this side, on the left side, we would have 5w plus 2w is 7w, and we still have the minus 29. And just like clockwork, same steps. So add 29, 55 plus 29. A little hard to think about here. So 55 plus 29, that gives us 14. So that would be 84. So some bigger numbers there you're not maybe used to. So 55 plus 29 is 84. Divide by 7. W is equal to 84 divided by 7 is, in fact, 12. So W is equal to 12. Okay. So what we have here, once again, goes back to talking about simplifying terms, is, well, if we have something flipped around, we can flip it around, okay, but we have to make sure, well, what's in front of our 2w? A minus. Now from here, we could have actually just added 2w to both sides, okay, just from up here, but just to make it very clear is if we move it around, we can actually really see that 2w is negative, so that's why we have to add 2w, okay, instead of subtract 2a like we had to do over here, okay. So once again, this was a positive 2a, so we had to subtract it. This is a negative 2w, so we had to add it, okay. And like I said, the whole point in that is to get rid of that term, but where it's an equation, if we do this to one side, we've got to do it to the other, okay. And then number 7 and 8, same kind of deal as what we just had, okay, where we've got 5p minus 11 equals 13p minus 43. So same kind of deal, both sides of the equation. We can't simplify it all, okay. So it's up to us to see that, all right, I can either do one of two things. I can either subtract 13p from both sides, or I can subtract 5p. And I'm actually going with the 5p. I'm going to subtract 5p to get rid of these, which over here, that gives me negative 11. So minus 11, negative 11. 13p minus 5p is 8p, and we still have the minus 43. And just like always, two-step equation, let's add 43. Negative 11 plus 43 is 32. It's equal to 8p. And divide by 8. So in this case, we get 4 is equal to p. All right, so if you've kind of caught on by now, you see how all these kind of work the same. It's just that when we're going to get into some harder ones here where we have to maybe do some distributing or combining like terms, because these have all been really easy in a sense that they already give you everything simplified except for there's a variable term on both sides, okay? Same thing when we look at number 8. If we split the sides here, well, we've got negative 50 minus c. Well, I can't, so minus 1c if you want to look at it that way. I can't simplify that any. I can't add, I can't subtract negative 50 and 1c, okay? I have to keep it like it is. Same thing here, 5c minus 2. I cannot add or subtract those numbers together because 5 has a c, 2 does not. So here we're at another impasse where we have variable terms on both sides. Well, you've got a choice. You can either, and I'm not going to flip it around this time because you can see we've either got negative 1c or 5c. Like I said, you've got a choice. You can either add 1c to both sides or subtract 5c. Well, I'm actually going to add 1c to both sides. To get rid of the 1c's, so I have negative 50. 5c plus 1c is 6c minus 2. And then two-step equation all the way. Divide by 6, divide by 6. Negative, in this case, that'd be negative 8 is equal to c. Now this one was a little tricky because once again we had the terms flipped around here. Maybe it's a little hard to see, but we just had a c there, so we can put a 1c, a 1 in front of the c. And if we add 1c to both sides, the 1c's over here go away, whereas this side, 5c plus 1c becomes 6c. And if it helps you do that too, you can box your little terms here and say, well, I got to get rid of one of these. I can either subtract 5p or subtract 13p, okay? I can either add 2w or I can subtract 5w, okay? I can subtract 6a or I can subtract 2a. And like I said, it all depends on what's in front of your term, okay? And also what sign. Well, technically, what's in front of your term, meaning what sign is it? Is it positive or is it negative? Okay. Then we get into something like number 9, and we'll admit this can get a little complicated here, okay, because we got to do a lot of different things, but this is really depending on you knowing how to solve a multi-step equation. Like I said, the only thing we're adding to it, so we got to do everything exactly the same. So if we need to distribute, we distribute. If we need to combine like terms, we combine like terms. The only thing is, before we get to the bottom, we have to do this thing where we add or subtract a variable term. So what I mean by that is if we look at number 9, well, I can actually simplify this by combining these two terms, negative 5x plus 3x to give me negative 2x. What's left over is the minus 16. And then over here, I can actually, so I'm going to do this to make it easier for me to see. I'm actually going to flip this around. Whereas, once again, I took this negative 9x and flipped it with the negative 23. So negative 9x minus 23. And then from here, we can see, well, we can't simplify this any further. Because once again, we've done all the simplification we can over here for number 9. On the left side, there's no simplification we can do on the right side. I just wrote it a little different way. But now we have a choice. We can either add 2x to both sides or we can add 9x to both sides. Okay? And it's really up to you. I'm going to add 9x because I can kind of maybe foresee a little bit that if I add 9x over here, that's going to give me a positive 7x minus 16. Versus if I were to add 2x, I would have a negative 7x over here. Okay? But these would go away, so we have negative 23 plus 16 plus 16. 7x is equal to, in this case, negative 23 plus 16 is negative 7. Divide by 7. X is equal to negative 1. Okay. So these are kind of getting a little bit more involved where, all right, I had to simplify the left-hand side before I could add or subtract a variable term from either side. Same thing's going to happen with number 10, except for the simplification is going to have to happen on the right-hand side. Because 6r minus 5, I can't do anything with that. That's simplified. Over here, though, I can look, well, my variable term is positive 8r, so that's all I've got variable term-wise over here. So I'm going to go ahead and write that. But then what's left over? Well, I have 1 and negative 24, which gives me a negative 23 or a minus 23. And once again, once we get to this point, it's just a matter. I can subtract 6r from both sides. I can subtract 8r from both sides. Okay? So it's up to you, but I'm going to say easier way here would be to subtract 6r because these will go away, giving me negative 5 is equal to 8r minus 6r is 2r minus 23. Two-step equation. So here we get 23. So negative 5 plus 23 is 18. Divide by 2, divide by 2. 9 is equal to r. Okay. So once again, the trick to these is simplify what you can. Okay. So whether it's, as you'll see when we get to number 13, is whether you have to distribute, whether you have to combine like terms, whatever, simplify both sides and then either add or subtract a variable term from both sides. Okay. And once again, the adding or subtracting is dependent on whether the term is negative or positive. So we're on the home stretch now. So last 6 questions here. Number 11, same kind of thing, except for we actually have to simplify both sides. Because 9a minus 7a, well, I can actually just add, or I can combine those two terms. 9a minus 7a or 9a plus negative 7a gives me 2a. Over here, I can combine the 3a and the positive 2a to give me 5a. What's left over is the minus 33. And now it's just a matter of, okay, well, I'm going to subtract 2a from both sides. You could have also subtracted the 5a from both sides, but once again, you can kind of be a little smart about it. So we get 0 is equal to 3a minus 33. And do our little two-step boogie here. 33 is equal to 3a. Divide by 3, divide by 3. So we get 11 is equal to a. But once again, this one is a little different, so I'm going to put some stars by that one too, because once again, we had to simplify both sides before we could do our little thing here where we add or subtract from either side. So add or subtract a variable term from either side. All right. Number 12 is actually going to be a little bit different than number 11 in that, all right, over here, there's nothing I can combine with the 7m, so I'm going to go ahead and write 7m. But I can combine the negative 5 and the negative 20 to give me negative 25. Over here, my variable term is negative 2m, and we have a positive 20, so 2m plus 20, negative 2m plus 20. Same kind of thing, so I can either subtract 7m from both sides or add 2m, which is exactly what I'm going to do. Because I want these to go away, so on the right-hand side I have positive 20. Over here I'm going to have 7m plus 2m, which is 9m minus 25. And once again, easy peasy lemon squeezy. 9m is equal to 45. Divide by 9, divide by 9. M is equal to 5. Okay. So once again, combine like terms, distribute, whatever you got to do. So numbers 13 through 16 here, we're getting ready to look at. They have to deal with you being able to distribute, okay? But at the same time, combine what like terms you can, all right? So that's the name of the game here, simplifying, combining like terms. The only thing we're adding is this step right here where we have to either add or subtract a variable term from both sides. And I can't stress this enough. It actually doesn't matter which one you add or subtract as long as you do it correctly, meaning if it's a positive term, you subtract that term. If it's if it's a negative term, you would add that term. Okay? So once again, just pay attention to whether it's positive or negative. That's indicated by what's in front of the number. Okay, what's in front of the term? Is it a minus sign, a plus sign? Or if there's nothing in front, it also means it's positive. Okay. So then when we get to number 13, here you start seeing parentheses. So same time, we block off the sides of our equation. Well, I can actually simplify this side over here because I can distribute a 4. 4 times k is 4k, minus 4 times 2 is 8. I can actually simplify the right-hand side too by distributing a 2. So we get 2k minus 18. I just want to point out that once we do that, we get the same thing we did on all the previous questions where we can either subtract 4k or subtract 2k. And I'm going to do the latter. I'm going to subtract 2k from both sides so I can get rid of these, which is going to leave me with negative 18. 4k minus 2k is 2k. We still have minus 8. And two-step equation time. So two-step equation time, TSET. So here we get negative 10. So we divide by 2. K is equal to negative 5. Okay. So whether it's distributing, combining like terms, you got to simplify both sides before you go on and do this little idea here where you add or subtract a variable term. Okay. But with all these questions in this section, that's a step that you have to do. Okay. So same thing on number 14. Distribute on both sides because you see parentheses on both sides. So let's distribute. So we get negative 6n. Negative 6 times negative 3 gives me a positive 18. 5 times 4 is 20. Minus 5 times n is 5n. So again, you've got a choice here, but I'm going to do a little thing here where I make it a little easier on myself. I'm going to switch these around to be 5n plus 20. Okay. So all I'm doing is I'm taking this term negative 5n, putting it out front, positive 20, putting it behind. So negative 5n plus 20, these are the same. Now I can see I can either add 6n to both sides or add 5n to both sides. Well, I'm going to add 6n. Okay, and the whole point is to get rid of those. So we have 18 is equal to negative 5n plus 6n is 1n. We still have the plus 20. I'm going to actually go ahead. Technically only a one-step equation here because if I subtract 20, I get negative 2 is equal to 1n, which is just n. Okay. So just to wrap this up, once again, every single one of these questions works the same in that you have to simplify both sides. And then, like I said, it's up to you. Get rid of one of the variable terms from one side by either adding the term, like in the case of number 14, or subtracting the term, like in the case of number 13. Like I said, getting pretty involved here, some pretty complicated equations, okay? But once again, if you can figure out how to do these last two equations, none of these equations should have any impact on you or give you any trouble because these are the hardest. If you know how to do the hardest, then the rest are easy, okay? The same thing here. I see parentheses, so let's go ahead and distribute there and distribute here. On both sides, once again, we have parentheses on both sides, so we do negative 8 times p, negative 8p, negative 8 positive 2 gives me a negative 16. We still have this plus p over here. On this side, we have 4 times p is 4p. Once again, this is equal. Times plus 4 times positive 3 is a positive 12. And we still have the plus 5. So once again, after we do that, let's simplify both sides. So we have to do something with this negative 8p and this plus 1p. Okay, so once again, you can go ahead and add the 1 in there if you need to. Negative 8 plus 1 is negative 7p. We still have the minus 16. And over on this side, well, we can't do anything with the 4p. It's by itself over there as a variable term. But we can add 12 and 5 to give us 17. Like I said, after all that mess, all those like terms, all that distributing, we get to this point and we have a choice, which I'm going to add 7p. We could subtract 4p from both sides, but I'm going to add 7p. So we get 4p plus 7p gives me 11p. And two-step equation. So negative 16 minus 17 is negative 33. Divide by 11, negative 3 is equal to p. And then the last one, and then I'll be quiet and let you work on your work there and practice with this. But number 16 is the grand finale here, I guess, on this. Which actually, I think number 15 is actually the hardest one out of these. The only thing hard about number 16 is you do have a fraction. But if you just pay attention to what you're doing, you're going to distribute the negative 1/2. So that's going to make this negative 6v plus 10. And then we still have the plus 4. And that's going to be equal to, I'm going to go ahead and do this just to make it to where my variable terms on the left-hand side here of the left-hand side of the right-hand side. No confusion intended there. But we just do the same thing. So over here, I can't do anything with this negative 6v, so I'm going to keep it negative 6v. But I can add 10 and 4 to give me 14. I can't do anything with the left or the right-hand side. So once again, we're at a place where we're simplified as we can be on both sides. So we just try to add. In this case, we'll add 8. We could also add 6, but I'm going to add 8 to get rid of those. So that over here gives me negative 12. Over here, negative 6v plus 8v is going to give me 2v. And then we subtract 14. 2v is equal to negative 26. So in this case, we get v is equal to negative 13. Okay. So with that being said, like I said, this can be a little tricky, so it's definitely important that you go through and work every single one of these problems out and you write down the steps because, like I said, you just look at this looks overwhelming because there's just a lot of stuff going on, okay? So with these, make sure you follow step by step, okay? And like I said, we kind of build on what we've been doing before. So in order to solve these equations, you have to know how to solve one-step equations, two-step equations, regular old multi-step equations, and then you also have to know how to solve, with this last thing, is know how to deal with your variable terms on both sides. So once again, either add or subtract depending on whether your variable term's positive or negative. Okay. So in this case here, I added 7p because I wanted to get a positive over here. I could have easily subtracted 4p and got a negative 11p over here. Okay. But either way, the equation will work out to be negative 3. This equation will work out to be negative 13. So it actually doesn't matter which side you pull the variable term from. Okay. Definitely practice a lot with this as you go through. There's actually one last page that has a bunch of riddles on it, or has a bunch of equations with riddles on it. I'm not making it mandatory that you go through and work every single one of those equations out, even though if you did, it would really help you because, I mean, there's a total of 34 equations there, which I will admit it's a lot of equations like this, considering how long each one takes. But if you can work every single equation out on that riddle on the back page, once again, you should have no problem with equations whatsoever at all this year or next year in algebra. I'll be honest with that too, because you're going to be doing a lot of this in algebra next year as well. Okay, so with that being said, is try the riddle. If you can do it, fine. If you can't, that's also fine, because I know it's an awful lot to put on you right there. But because we kind of technically did 2 sections in one, but I would take it step by step here and say, and make sure you know how to do the multi-step equations with variables on one side. And then once you've got that down, go to the multi-step equations with variables on both sides. Like I said, it can get pretty messy because look at this. I mean, if you didn't see what we just did, that looks very messy in terms of things circled. There's things crossed out. There's a bunch of numbers and variables and stuff everywhere. But it all started with this very top equation. And like I said, take it step by step, and it works out in the end. Okay. So with that being said, try your best on the homework. Technically a total of 24 equations on homework. So that's another reason why I say you don't necessarily have to do the riddle part. Okay. That's just extra practice in case if you are really struggling. I do strongly suggest going and practicing, going down the list there, seeing if you can't figure out the riddle. But at the same time, I don't want to overwhelm you and give you 24 homework questions on top of 34 practice questions, okay? So, because once again, that's a lot of questions. But at the same time, the more you practice with these, the better you get, okay? So if at any point you get confused, I suggest maybe stopping it, pushing back the video a little bit, and just taking it step by step. And that's the way you got to approach these things, is step by step. And then once you do it step by step, each step means you're closer to the solving than before. Okay, so with that being said, good luck on your homework. And if, as always, if you have any questions, please let me know. And also, as always, thank you for watching.